Alright, here we're looking at exponential equations. Now, this one right here is written wrong. It should be x6 to the x power. So I'm not actually doing anything different to it, so it should be 6x and 6 to the x power, two different things. So 6 to the x power. Alright, now let's look at the bases. The bases are the same, so we'll end up with x is equal to 3x minus 4. Okay, I'm going to bring the 3x over to the other side by subtraction, so I'm going to subtract 3x from both sides. Okay, now they have different signs. Okay, remember this is like having one x in front of it, so we end up with negative 2x is equal to negative 4. Now remember to bring down that minus or negative sign with it. Okay, and then we just divide both sides by negative 2. So x is equal to different signs, and we're dividing, so it's going to be positive 2. Alright, let's look at number 3 here. Same base. So let's write 3x is equal to 2x plus 1. Okay, I'm going to move the 2x over. So we end up with x is equal to 1. Now if we look at number 5 down here, they don't have the same base yet. So we're going to have to write the 9 in terms of the 3. So we'll go 3 squared. We're going to replace 9 with 3 squared, and then x plus 1. So we're going to have to distribute this 2 through here. So I'm going to write 4x, because they have the same base now. So bring down 4x, distribute the 2, so it's going to be 2x plus 2. Okay, I'm going to move the 2x over to the other side. And so we end up with 2x is equal to 2. Divide both sides by 2. And we end up with x is equal to 1. Alright, here for number 7 we have an inequality. The main difference between equal sign and inequality is equal sign is going to give us, not an equal sign, but inequality will have multiple answers that can go in there. Now, as far as how we would solve, we're going to treat it the same as an equal sign, with the exception if we multiply or divide by a negative, we have to reverse the inequality. So let's look at that. So, same base. So we'll write x plus 3 less than or equal to 2x minus 4. Okay, get like terms together. Now, with this one, you can move either way. I want my variable on the left, so I'm going to subtract 2x from both sides. Now again, you can move it the other way, so we end up with negative x plus 3 is less than or equal to negative 4. Remember to keep this together when we bring it down here. Okay, now I'm going to subtract 3 from both sides, so we end up with negative x is less than or equal to negative 7. Now our inequality here, and we're going to have to reverse it because we don't leave variables negative, so we're going to divide both sides by negative 1. Now when we divide by that negative 1, we're going to have to switch our inequality. So we end up with x is greater than or equal to 7, because we're dividing by negative. So we have a negative divided by negative, same signs as positive. Now if you had moved the negative 2x, if you move the x over to the other side, here I'll show you what would happen. You end up with the same answer. Now it may look a little bit different. Okay, if I subtracted x from here, so bring down the 3 is less than or equal to x minus 4. Then we would add 4 to each side, and so we end up with 7 is less than or equal to x. Now here we didn't have to switch our inequality because we didn't multiply or divide by a negative. Now these may look like different answers, but they mean the same thing. If you notice, one way to remember it is they have to be pointing at the same thing. So here 7, our inequality is pointing at 7. So 7 is less than or equal to x is the same thing as x is greater than or equal to 7. It's just two different ways to solve it. It means the same thing, same answers. Alright, let's look at number 9 over here. Okay, we have the same base, so I'm just going to bring down 2x plus 1 is less than or equal to 3x minus 3. Okay, now I'm going to move the 3x over again, because if we had to graph these, sometimes it's simpler to graph them if the variable's on the left. So anyway, so we have 2x minus 3x, we end up with negative x plus 1 is less than or equal to, again, we'll have to bring this down as negative 3. Then subtract 1 from both sides, so we end up with negative x is less than or equal to negative 4. Divide by negative 1. Okay, we're dividing across the inequality since this right here is moving across the inequality. Okay, it's moving over here. Okay, and it's negative. We're going to have to reverse the inequality. So we end up with x is greater than or equal to 4. Now, if you'd have moved it the other way, you would have ended up with 4, okay, is less than or equal to x. So those mean the same thing. Alright, finally let's look at number 11 here. We want the same base, so we're going to get it in terms of 25. 25 in terms of 5. So I know 5 squared gives me 25. Okay, again, we're going to distribute the 2 through. So we end up with x plus 2 is greater than or equal to 2x minus 4, because it's 2 times x gives me 2x. 2 times negative 2 gives me negative 4. Okay, now subtract 2x from both sides. I end up with negative x plus 2 is greater than or equal to negative 4. Okay, subtract 2 from both sides. So get negative x is greater than or equal to negative 6. Divide both sides by negative 1. We're going to switch our inequality so that we get x is less than or equal to 6. Okay, so hopefully that helps you with those. Main thing is get the same base. Okay, then we can put the exponents equal to each other, and then we can solve. And just remember that with inequalities, we have to reverse the inequality if we multiply or divide by negative across the inequality.